All right, this is AP, AB, and BC Calculus. We're doing Unit 5, Section 11, which is solving optimization problems. Basically, we're just going to be using the skills we did in the last video, 5.10, to do some slightly harder optimization problems in this video. All right, so example 1. What are the coordinates of the point on the curve y equals 2x minus 3 that is closest to 3, 0? Okay, so first thing we have to do in any optimization problem is determine what quantity we are trying to optimize, right? The big hint it's optimization is this EST, right? These superlative adjectives. So closest to 3, 0 means the minimum distance. So the equation we're going to want to use is the distance formula. So my equation is going to be that the distance, so we want the minimum distance from some x comma y to 3, 0. Right? So what that's going to look like is the distance formula is the square root of x minus the x value quantity squared plus the y minus the y value quantity squared, right? So what that's going to look like is my distance is going to be the square root of, now it's up to you if you want to FOIL this out, but what I want you to notice here is that there's too many variables, right? So too many variables. So I need that auxiliary equation. The nice thing about these distance formula problems is that the auxiliary equation is handed to you because the point xy is on the curve y equals 2x minus 3. So I'm going to go ahead and replace that y with a 2x minus 3. So I get x minus 3 squared plus, and then it's a y minus 0, but you could just call it a y, right? So y squared, which would be 2x minus 3 quantity squared. So there's the thing I want to minimize. So minimize this. So you can, if you so choose, FOIL out the stuff on the inside of the root. I promise it's not going to make a huge difference. When I differentiate, right, so I want d prime of x, right, essentially. So remember that this is this whole thing to the 1/2. So what's going to happen, right, this whole thing is this x minus 3 quantity squared plus a 2x minus 3 quantity squared. Whole thing is to the 1/2, right? So when I differentiate, I'm going to get a 1/2. This whole thing, this x minus 3 quantity squared plus 2x minus 3 quantity squared to the negative 1/2, and then I'm going to have to differentiate the inside because of the chain rule. So the derivative of the inside is going to be 2x minus 3 now to the first plus a 2x minus 3 to the first times the derivative of the 2x minus 3, because here the derivative of the x minus 3 was just a 1 anyway. So what this is going to end up looking like, and it is one of those things where it's kind of worth memorizing that when you differentiate a square root, you get 1/2 times that square root on the bottom because it happens a lot. So I'm going to get this on the bottom. And it's the top that's actually going to be interesting to me. This is going to be a 2x minus 6, so 2x minus 6. And this is going to be a 4 times this stuff, so a 4 times the 2x would be an 8x minus a 12. So I'm going to get that my d prime of x is going to be a 10x minus 18 on top of this stuff. Now, you might think, oh, this is still awful. I have to find the critical numbers, and it's terrible, et cetera, et cetera, et cetera. Okay. The thing is that all of these distance problems actually have a trick. So here's the trick. Recall that this thing, this root, was the distance, right? So really what this is looking like is that d prime is 10x minus 18 over 2 times the distance. Well, why is that relevant? The distance can't be 0 because 3, 0 isn't on, that's not how you spell isn't on the curve y equals 2x minus 3, right? So you have this line, y equals 2x minus 3, and you have the point 3, 0, right, which is, so let's just say it looks kind of like this. You have the point 3, 0. See how that point is not on this line? That means the distance between them can't be 0. So the only critical point, right, so the only critical number that you're going to have is when the top equals 0. So 0 equals 10x minus 18. X has to be 18 tenths. You can either make that a 1.8 if that's where you feel comfortable, right? So if you want to make this a 1.8, you can. If you want to make it a 9/5, you can. I don't care which one you pick. You were asked for the point, so you do need to find the y value, but notice that you can easily find the y value by plugging into y equals 2x minus 3. So once we know that x equals 1.8 is the only possible contender, y is 2 times that 1.8 minus 3, which is going to be a 3.6 minus 3, so you get y is 0.6. And your answer is 1.8 comma 0.6. Now, I'm able to say this because after years and years and years of trying to find the critical numbers for this denominator, it took me a very long time to realize that I kept never, ever, ever getting any critical numbers based on the denominator equaling 0. And then one day I had the epiphany that that's because the denominator is just double the distance, and the distance can't be 0. So when you see one of these problems, even though it looks really horribly long, honestly, as soon as I get here, I know that that's going to be the value that gives me my answer, having done this for literal decades. All right, so try P1. It's the same exact idea, except you have a different curve, right? And as you'll notice, 5, 0 is not on this curve. So again, that distance can't possibly be 0, okay? So let's go ahead and walk through this. You can pause me if you don't want me to. Remember that what this is saying is minimum distance. That's what it means to be closest, right? So the distance between these 2 points is the square root of x minus 5 quantity squared plus y minus 0 quantity squared, right? Or if you get rid of that minus 0 because you don't need it, x minus 5 squared plus y squared. Now again, you can definitely FOIL out the x minus 5 if that's more comfortable for you. It doesn't really matter. Either way, I see I have way too many variables, so I'm going to go ahead and make this an x minus 5 quantity squared plus an x plus 2 quantity squared, because I can replace that for y. I know I need d prime, right? So d prime, again, I'm used to differentiating square roots, and I know that this is what the bottom's going to end up looking like, right? So it's 1 over 2 times the square root of whatever was inside the square root, right? And then I just need the derivative of the inside, right? So the derivative of the inside of the root, right? Which is going to be a 2x minus 5 to the first times a 1, because when you differentiate the x minus 5, you just get a 1, and a 2x plus 2 to the first, again, times a 1, because when you differentiate the x plus 2. So the inside ends up being a 2x minus 10 plus a 2x plus 4 all over this thing that, again, we've established is actually just 2 times the distance. So my d prime ends up being a 4x minus 6 on the top, which means that I know the only critical number, right? So the only possible critical number that makes any sense, since the distance can't be 0, is when 4x minus 6 is 0, so when x is 3/2 or 1.5. Once I know that, I can say that the point has to be y equals 1.5 plus 2, which is 3.5, and my answer, and again, I don't care if you put it in fractions or decimals, is 1.5 comma 3.5. Right? And I don't have to put too much work into figuring out that that's the minimum value because it's the only critical number I have. If you're asked to find the coordinates and not given the out of, if there is no minimum, explain why, then you don't have to worry. They wouldn't ask you to find a minimum if it didn't exist. All right. E2. A company has started selling a new type of smartphone at the price of $130 minus 0.1x, where x is the number of smartphones manufactured per day. The parts for each smartphone cost $60, and the labor and overhead for running the plant costs $4,000 per day. How many smartphones should the company manufacture to maximize profit? Okay, so you need to maximize profit. Well, in order to do that, you need to know what profit is. So profit is the income minus the cost. So let's look at what the cost is. So the cost in terms of x is $60 per phone, and and again, all of this is daily, right? Daily profit, so daily cost, right? Daily income. So the cost is the $60 per phone plus the $4,000 that you have to pay just for the single day. The income that they are making for each phone is 130 minus 0.1x. So each phone is 130 minus 0.1x. That's the price times x. Times x phones. That's how much you bring in, right? So that's the price per phone, right? Notice that the price is lower if they make more phones, right? And that actually makes sense, right? The more phones that are produced, usually the cheaper the sale price. So this is the number of phones. All right, so what we're asking is, we're asking for profit, which is income, this thing, minus cost. So the profit is going to be 130x minus 0.1x squared minus, in parentheses, the entire cost function, which is a 60x plus a 4,000. When I clean this up a little, my profit is going to end up being a negative 0.1x squared. I get a 130x minus the 60x, so that's a plus 70x. And then when I distribute the negative here, I get a minus 4,000. Now, there's probably at least one person watching this video that thinks, wait a second, this is a parabola, right? You're probably thinking, wait a second, it's an x squared with a negative leading coefficient. Hey, there's the max. Is it cheating to use your Algebra 2 knowledge to say that the max has to happen at negative b over 2a? No, it is not cheating. Congratulations, Algebra 2 is helpful. If you do this, negative b would be a negative 70, right? And 2a would be a negative 0.2. So if you have a calculator, great. If you don't have a calculator, you have to do a little bit of heavy lifting, right? So this is a negative 70 over, if you want to make it a 2, well, I'm just going to do positive 70 over positive 2/10, right? So this ends up being a 700 divided by 2, right? Which ends up giving you a 350. So the answer is apparently they should make 350 smartphones, right? So if you chose to use Algebra 2 to figure this out, answer 350 smartphones. Great. Right? If you chose to use Algebra 2 to figure it out, nobody thinks that's cheating, it's fine. If you wanted to use calculus to figure this out, your p prime is going to be negative 0.2x plus 70. You would want to know where your critical numbers are, right? Your critical numbers are when p prime is 0. Well, look, that's going to get you to exactly the same spot as your negative b over 2a. It's going to get you to x is the 350. It's going to be the only critical number, and sure enough, that's going to be your max, right? Again, the Algebra 2, all of this stuff that we learned has roots in calculus and is easier to understand if you know calculus. It is not wrong to use prior knowledge from Algebra 2 to work through a problem. All right, so try P2. A rectangular field adjacent to a riverbed is enclosed. Fencing along the river costs $5 per meter, and fencing along the other sides costs $3 per meter. The area of the field to be enclosed is 1,200 square meters. Find the dimensions of the field that is the least expensive. Okay, so least expensive, right, means minimum cost. So what you have to write an equation for is cost. So what we need to be aware of, so let's go ahead and draw like sort of a picture just so we have a little bit of an idea. There's a river, okay? So we have a rectangular field, right? I'm going to call these sides x. I'm going to call these sides y, right? So the cost to make this thing, right? The cost to make this thing is going to be these three at the $3 rate, right? So these three, right? So the non-river side, right? The non-river sides cost $3 times essentially 2x plus y, right? That's the cost for the non-river side, plus the cost for the river side, right? The cost for the river side is $5 times y, so plus 5 times y. That should be my cost, right? So if you want to clean this up a little bit, you get that cost is 6x plus 3y, right, plus 5y, so plus 8y. Great. The problem is that that's still too many variables. I really need to get rid of x or y. So I need some other piece of information. And the other piece of information is that the area to be enclosed is 1,200 meters. So my auxiliary equation is that x times y, right, because that would be the area, xy is 1,200. So I'm going to go ahead and let y equal 1,200 divided by x. So that means that I get that the cost is 6x plus 8 times 1,200 divided by x, or my cost is 6x plus, again, I don't really think that you have to clean this up to 9,600, but you can if you want, and I'm going to make it an x to the negative first because that's easier to differentiate. This is the thing that I want to minimize, right? So once we get the equation, it's actually not awful to do this, right? So my c prime of x is going to be a 6 minus a 9,600 x to the negative second. Now I would suggest, that's actually a 6 over 1, right? I would suggest getting a common denominator of x squared because you're going to have an easier time with this if you do. So if I want to find where c prime is 0, right, because I want to find my critical numbers, I'm going to get that it's when 6x squared minus 9,600 is 0, right? I can yank out a 6, right, and I would get 100, 15, right, so 1,500 and 100 should be 1,600. Does that check out? That checks out. There we go. All right, so equals 0, right? So I'm going to get that x is plus or minus the square root of 1600, right, which is 400. Now, the trick is that minus doesn't make sense. The other critical number I get is when c prime does not exist, which would be x is 0, but the only credible, right, the only credible critical point is x equals 400, right? And the reason for that is because it doesn't make sense to have a negative, so no negative or 0 side length. That makes 0 sense. You can't have that in this context, right? It wouldn't logically make sense. So the only critical point that makes any sense is 400. You could definitely differentiate and figure out that that's the only credible critical point, but it's the only one that would work in the sense that x and y here, right? So there's a domain restriction that both x and y, not even greater than or equal to 0, just strictly greater than. X and y both have to be greater than 0 logically in the context of this problem. So honestly, I would go ahead and say, cool, so that's my only critical point. X is definitely 400. Once I know that, they want to find the dimensions, so I'd have to find y, right? And we know that y is 1200 divided by x, right? So y is 1200 divided by x, which means y is 1200. I did something crazy. That's a 40. Sorry, people. That's a 40. Anyway, 40. So 1200 divided by 40, right? So, and I'm not going to say that that's equal because it's not. I'm going to put an arrow. So I have to get 30. So x is 40 meters, and x is the side that runs perpendicular to the river, right? And y is 30 meters, and that's the side that runs parallel to the river. Now, if you have a diagram that shows that, as we did, it's totally fine. Sorry that I accidentally square rooted 1600 and got 400, which makes no sense at all. Okay, so moving on. Sometimes my brain doesn't function properly. All right, consider all the lines in the xy plane that pass through both the origin, right? So this black line, the origin, and some point xy on this graph, x squared minus 3x plus 4. We're looking only between 1 and 3, right? So from 1 to 3. The figure below shows one such line. What is the point, x comma y, such that the line will have the minimum slope? All right, so we need to figure out what the slope of this line is. Well, the slope of this line, right, in terms of x and y, and you can't assume that x is like 1 and y is 2 because that's not true. This x comma y for a reason, right? We go up y units and over x units. So the slope is y over x, right? Rise over run. Now, technically, it's y minus 0 over x minus 0. If that's how you wanted to do it, that's fine. So this is the thing that I want to minimize, right? I want to minimize slope. But I still have too many variables, right? There's too many variables. So I need some sort of an auxiliary equation. Well, thankfully, I know a thing or two about this x and y. Specifically, I know that they lie on this curve. So I could replace the y's with an x squared minus 3x plus 4 all over an x. And now I could differentiate. Now, it's your call. I'm not going to differentiate as is because I think that's miserable. So I'm going to split this into 3 fractions because I can do that with a monomial denominator. And I'm going to make my slope x minus 3 plus a 4x to the negative first. So now when I find m prime, that's a 1. The negative 3 differentiates to 0. And then minus a 4x to the negative second, right, which I'm going to rewrite as an x squared minus 4 over an x squared, right, because I'm going to recognize that this is a 1 over a 1 minus a 4 over x squared and get a common denominator. So now I have that this is my m prime, and I'm going to go ahead and find my critical numbers, right? So my critical numbers are the following spots, right? Either m prime is 0. Well, that's going to be when x squared minus 4 is 0, which is when x is plus or minus 2. Or my m prime does not exist, which is going to be when x is 0. And that can't possibly be the point, right? Because among other things, you can see that when x is 0, you can see that when x is 0, I wouldn't have a line, right? Like if, well, I guess I would have a line. I'd have a line with a vertical slope. I lied. I take it back. I would have a line, but it's definitely not the answer. So, okay, so I would also make the argument that if you look at these choices, I now have 3 critical points, negative 2, 2, and 0, but I was told that I'm only allowed to use the window from 1 to 3, right? So I have those 3 critical points, and I also have endpoints. I have x equals 1 and x equals 3. So it's up to you if you want to do this as a sign chart. I would argue that there are 5 possible I'm sorry, not 5, 4 possible, 3 possible contenders. These are not in the window, right? So I'm going to go ahead and make a sign chart for this. I'm going to start at 1, then 2 is the critical number I got, and then 3, and then I don't need the stuff after, my bad. So again, because I had endpoints. So now here are my factors. I have an x plus 2. I have an x minus 2, because that's what x squared plus 4 is, right? X squared plus 4 is an x plus 2, x minus 2, right? And I have an x squared. Now keep in mind that an x squared is always positive except at 0, right? So when I make my sign chart for m prime, and again, you don't have to make a sign chart, but there are 3 critical points here, so you would be guessing if you didn't. So I know that both of these are lines with positive slopes, right? But x plus 2 has its 0 at negative 2, and it's always positive after. And you can see that by plugging in any of these numbers. X minus 2 is 0 at negative 2. It's negative before it, or I'm sorry, at positive 2. It's negative before it hits that 0 and positive after. And then x squared is always positive, so I get negative and then positive, which means that what the slope is doing is decreasing and then increasing. So this is my minimum. So after all that work, I'm able to find that the minimum possible slope is at 2. So my answer is when x equals 2, and they say find the point. So my answer is 2 comma blank. To find the y value, I need to use the original function, right, which was y equals x squared minus 3x plus a 4 maybe? Yep, plus a 4. So when I do that, I get that y is 4 minus 6 plus 4, which ends up being a 2 comma 2. All right. Let's try a P3, which is the same concept. So again, you're finding minimum slope. It's basically exactly the same question. You have a rise over run. The only difference is which formula I gave you for y. So my slope is y on top of x, but I need to recognize that that's too many variables. So that's an x squared minus 4x plus 5 over x, which I'm going to rewrite as an x squared over x minus a 4x over x plus a 5 over x. So my slope is x minus 4 plus 5x to the negative first. When I differentiate, I get 1 minus a 5x to the negative second, which I'm probably going to rewrite as an x squared minus 5 all over an x squared. So when I want my critical numbers are when x squared minus 5 is 0, which is going to be at x equals plus or minus the square root of 5. And when x squared equals 0, which is at 0, right? Because that's when m prime does not exist, and this was when m prime was 0, right? So those are my critical numbers, but I was given a window from 1 to 4, so that's this window here. So I also have endpoints at x is 1 and 4. What that means is that 2 of these critical numbers aren't going to be relevant, right? Negative root 5 and 0 don't fall in the interval from 1 to 4. Right? Root 5 does, because root 5 is a little bit more than the number 2, right? Because root 4 would be 2. These don't fall in the interval. So when I look at this, I'm only looking at the 1, the root 5, and the 4. My factors were x squared minus 5, right? Now that's a parabola that looks like this, right? With its zeros at the root 5s. So it's going to be negative and then positive, right? Because you can see that that's this window here, negative and then positive. X squared is positive all the time except at 0, right? So what that means is that my m prime is negative and then positive, so m is decreasing, then increasing. Sure enough, my minimum happens at root 5. Once I know the minimum's root 5, right, so my answer is root 5 comma blank, and in order to find the blank, I need to use the I need to use y equals x squared minus 4x plus 5. So that's going to be root 5, quantity squared, minus 4 root 5 plus a 5, which is going to be 5 minus 4 root 5 plus 5. So I'm going to end up with a 10 minus 4 root 5. That's the best I can do. And that's my minimum slope. All right, moving on. A supermarket employee wants to construct an open top box from a 14 by 30-inch piece of cardboard. To do this, the employee plans to cut out squares of equal size from the 4 corners so the 4 sides can be bent upwards. What size should the squares be in order to create a box with the largest possible volume. So I want to maximize volume. So let's look at what this is. So basically what's happening is you're getting a sheet of cardboard, 14 inches by 30 inches, okay? And you're taking a corner that is x by x. We don't know what x is, right? X by x, x by x, x by x. And we're going to assume here that the person is probably actually leaving like little cardboard tab pieces that they could actually glue, because otherwise it's not a very good box. So what's going to happen is that these corners are going to get removed, right? These x by x squares are going to get removed. And then along these dotted lines, the box is going to get folded up, and what it's going to turn into is a box that kind of looks like this, right? Sort of like the box you might see a bunch of soda cans in, right? If there's just freestanding bunch of soda cans, or like a cat litter box, right? Just a sort of low box, right? So things to notice. This X, right, the flap that I removed, that's how high the box is going to be. The larger the flap that I removed, the taller the box is going to be. This measurement, the whole thing was 14. So this is going to be a 14 minus 2x. And this whole thing was a 30, which means that this length is going to be a 30 minus the 2 x's I cut out. So the volume of the box is the height times the length times the width, although I don't think I'm writing them in that order. So there we go. That's the thing I want to maximize. So max this. I would suggest that you don't, like, dealing with three products together is pretty horrible. I would suggest it's worth foiling this out. I would do the algebra. I just think it's an easier option. If I foil, the first should be a 420. Outer is a negative 28. And inner is a negative 60. So that's a negative 88x, right? And then last is a plus 4x squared. So if I clean that up a little bit more, I get that the volume is a positive 4x cubed minus an 88x squared plus a 420x, right? So now, since I want to max this, I want to find the extrema, I need v prime, right? V prime is going to be a 12x squared minus a 176. I think that checks out. 176 x plus a 420, right? So I need I need those critical numbers, right? So critical numbers are either when v equals 0, v prime equals 0, or v prime does not exist. Well, the does not exist is not super relevant here because there's no denominator, and there are no endpoints, but there is logic that says x is not negative, and so actually I shouldn't say not negative, I should say x is greater than 0, because you can't cut nothing out, you wouldn't have a box, right? So there is logic, so we'll say but logic tells me that x has to be positive because you can't cut negative or 0 out of a box, and specifically x has to be less than 7, because if you only have 14 inches here, you can't cut 7 and 7 out of the two sides of 14, because then you would have no box at all, right? You'd literally just be cutting your cardboard in half. So logic tells me that any value outside of the window from 0 to 7 is not going to make any logical sense. Now I'm going to be honest, this is not super fun. If you were going to cave and just use the quadratic formula, I would support it here. I'm going to be a little bit lazy for a sec and see if I can factor out a 12 from a 176, because I'm tired and it's been a long day. I cannot. So let's see what we can take out. 176 is not a multiple of 3, so the best I can take out is a 2 and a 2 again. So I can take out a 4, and I can take out a 4 of that. So I'm going to take a 4 out and see what happens. So I can take a 4 out of this, and if I do, I get a 3x squared minus a 44x plus 105, right? Which still isn't super awesome or much better, but at least now I know that I could set this equal to 0, and that's slightly better. This may not get better. Sometimes you just have to cave and use the quadratic formula. So I'm going to go ahead and cave and do that. I'm going to say, cool, so thank you, quadratic formula. This is as far as I get without, like, my brain doesn't see that this factors. So we're going to say negative b plus or minus the square root of b squared, which will be a 44 squared, doesn't matter that it was negative because we're squaring it, minus 4 times 3 times 105, all over a 2 times 3. If you have a program on your calculator for the quadratic formula, which I don't know if I do on this one, oh hey, there we go. you could make your life a little easier. 3 times a negative 44, or sorry, it's a negative 44, and it's not times, and then a 105. Now, if you have the quadratic formula, you could argue that you don't even bother. Oh, hey, it does factor. I just didn't feel like dealing with it. So it does factor. I just didn't want to deal with it. So it's a 35 thirds and a 3, right? So apparently, when I do this, I get 35 thirds and a 3, which, by the way, allows me to reverse engineer that this definitely factors into a 3x minus 35 and an x minus 3, and we can verify that that's true. Hey, legit does work. So this factors into this. How nice of them. And there was a 4 in the front, which is relevant. So if I make my v prime sign chart, because I do now have 2 possible candidates that are legit, right? So I'm going to go ahead and put the logical endpoints on here because, again, logic told me that I couldn't pick a negative x, and also that it wouldn't make sense to take more than half the box. The 3 factors are a 4, because I did take out that GCF, and had it been negative, it would change my entire sign chart. And then these 2 factors. So the 4 is always positive. Sorry, it's my 35 over 3 is bigger than 3. My bad. So if I go ahead and fill this out, 35 over 3 is 0 for this function, and it's negative before it becomes positive. This one's 0 here, and negative before it becomes positive. And so I end up getting that my v prime is positive, negative, positive, which, by the way, totally fits, because if you look at v prime, it was ax squared plus bx plus c with an a that was positive, so it's definitely this. So once you know that, right, once you know that it looks like this, you know that v is increasing, decreasing, increasing. That means your max is right here, right? Your max is at 3, not 35 thirds. So now you could also make the argument, oh, hey, 35 thirds is more than 7. I didn't need to do that. Hang on. 35 thirds is more than 7. So I already knew it wasn't going to work. I could have stopped and not made the sign chart. If you did the logical thing, you'd see that this is over 7. Sorry, my brain was tired. So the only logical answer, what's going to happen is 7 actually falls like here. So what's going to happen is that this min is impossible, like in a real world problem. It's possible with the mathematical equation, but it's not possible in the context of this problem. So your answer is that x is 3 inches, right? And they asked, make sure you go back and actually answer the question. The thing you were asked to do is, what is the largest, what size squares should be cut? So that's the answer. So they should be 3 by 3 squares. And that's it, right? So you always want to make sure you go back and read the actual question. So the answer, right, if I come, so cut 3-inch by 3-inch squares, right? Make sure you go back up and answer the question. It's very frustrating if you do all the math right and don't answer right. All right, let's do a P4. Okay, same exact problem, except it's 10 and 16 instead of whatever the last one was, 14 and 30. So it's the same problem, 10, 16, you're cutting these x's out of the corners. And I don't mean to sound cavalier about it when I do these problems, but if you've done enough of these, you start to realize that a lot of them are the same problem with sort of different wrapping paper, right? Like it's meant to look different. It's not really different. It's the same problem. Now this one is literally identical to the last one with different numbers. But even when they come up with some creative other ways to measure these things, really it's often the same old problem in sort of different trappings. All right, so again, you want the largest possible volume, right? It's what size squares should be cut. So you want to maximize volume, right? To do that, you need to write the volume equation, which is going to be x times the 10 minus 2x times the 16 minus 2x. Now, there's almost always somebody who spots that there, like in a problem like this, there's a GCF that you could pull out of this that's a 2, and a GCF that you could pull out of this that's a 2, and that might make your life a whole lot easier. It's entirely up to you. If you wanted to spot that you could pull out a 2 from here, right? In fact, you could probably just pull out a negative 2, and you could pull out a negative 2 from here. You might want to say, oh, look, that's a 4x at the front, and now it's just an x minus 5, which is a lot easier to FOIL, and this is an x minus 8, which is a lot easier to FOIL. It's up to you. It gets you to the same spot eventually. So if you FOIL, you get x squared. Minus 8 and minus 5 would be a minus 13x, right? And then when you do the last, you get a plus 40. Right, so so I get that my volume is a 4x. So you could even arguably keep the 4 out, and I'm going to show you why that's kind of useful, because if you recall in the last one, there was a point where I had to spend a fair amount of time recognizing that I could take a 4 out of this, right? So it took me a while to figure out I could take a 4 out. if you are a little more heads up than I was and you leave the 4 out front, you could just basically leave the 4. When you differentiate, it's just going to stay as a coefficient of 4, right? So it might make it a little bit easier to factor. You don't have to do it that way. I'm going to go ahead and leave my volume like this, right? So then my v prime, right? This is just a coefficient, so I can just differentiate the stuff inside the coefficient, right? So that's going to be a 3x squared minus a 26x plus a 40, which didn't involve me having to take that nasty DCF of 4 out. So that was kind of a nice, clever trick. You don't have to see it. That's fine. It's up to you. So I don't know off the top of my head if this factors, right? I could. I didn't actually spend the time last time to figure it out. It might. We'll find out. 2 and 20 is looking pretty good. So let's see. So my v prime is going to be a 4. I'm gonna try this as a 3x and an x, right? If I want a 26, I think I need the 2 opposite the 3, that's 6, right? And the 20 opposite the 1, and I know that they have to have the same sign and that sign is both negative. So there you have it, right? So I end up getting that my v prime is 0 when either 4 equals 0, which is a lie, or when 3x minus 20 is 0, which is going to be x is 20 over 3, and we'll talk about whether that makes sense in a sec, and x minus 2 is 0, which is x equals 2. So again, I'm going to talk about logic for a sec, and notice that there are some restrictions on x. X can't be negative. You can't cut something negative out of the box. That would be like gluing stuff to the box. And I look at the smaller side, and I recognize that x can't be half the smaller side, because if I cut 5 out of, like if I cut a 10-inch long side in half, it would just not be a box. It would just be 2 pieces cut in half. Well, 5 is half of 10, so x has to be smaller than 5. Once I recognize that this one is bigger than 5, so this is not in that window from 0 to 5, honestly, this is the only possibility in contention. Now, if you don't spot that, you're going to have to make the same sign chart that I started to make last time, but this is the only viable critical point, because you can't cut the box, you can't cut more than 5 inches or even 5 inches total out of the box. So once I recognize that this is the only viable critical point in this particular, so this is the only viable critical number in this particular word problem, because it would not make sense to cut more than half of the box out, then I can say that I should be cutting 2-inch by 2-inch squares. And that's okay, right? If you make a mental leap, you can say that. You can say, I made this mental leap, I can't cut more than 5 out. I can't even cut 5 inches out. All right. So I think these are our last 2. And then we'll move on from this. All right, so a person in a rowboat 2 miles from shore at the nearest point, so there's the 2 miles, right, and there's the boat, wishes to reach a house that is 6 miles farther down the shoreline. If the person can row at a rate of 3 miles per hour and walk at a rate of 5 miles per hour, find the least amount of time required to reach the house. Okay, so the issue is, right, that we need to label a couple things, right? So I'm going to go ahead and call this amount x. I'm going to call this amount, the amount that they're walking, y, right? Oh, I lied. I'm not going to use x and y. Hang on. I'm going to call that y, and I'm going to call this amount 6 minus y. That's what this side's going to be, right? That side's going to be 6 minus y. Okay, so the issue here, right, is that they're going to walk, I don't know if that's the best variables. Hold on. So the issue is that this is the path they're taking, right? I know that this piece right here, right, this piece, the person is moving at 3 miles per hour. And once the person starts walking, which is right here, they're going to walk at 5 miles per hour, right? So essentially, I need a way to look at those two distances, and what I want to do is I want to minimize the time, so least amount of time. So I need to figure out an expression for how long it will take the person to cover this ground. Okay, so in order to do this, we need to do a couple things. So I'm going to go ahead and I'm going to call this, let's just call this y, okay, and let's call this x. So we're looking essentially at a situation where y squared is x squared plus 2 squared, because that's a right triangle, right? That would make this blue portion 6 minus x, because the whole thing is 6 and x is the part of the triangle, right? So here's what I know. I know that if I want, so speed, right, your speed is your distance divided by time. So if I wanted to solve for time, I would multiply time over and divide speed over. So time is the distance divided by the speed, right? So if I want the time it takes to do the blue thing, it's going to be the distance, right? So the distance, which is 6 minus x, divided by the speed, which is 5. So the time that it takes to do this, right, the time is going to be y, which is the distance of the red bit, divided by the speed I'm moving when I'm on the red bit, plus the distance on the blue bit divided by how fast I move on the blue bit. Now that's fine, right? And I'm going to go ahead and I'll use just t for time instead of the word time, right? So I want to minimize time, right? That's what I want to do, minimize time. The problem is that this is too many variables. And you saw me hemming and hawing a little bit about assigning the variables for this problem because honestly I've never done this problem, and that's part of the thing that you should see. I could go back and redo the video where I don't debate what I want to assign my variables as, and there are other ways to do it. I could have done the original variable assignments that I did. But what I want you to see when you watch these videos is I want you to see that even when you're someone who does an awful lot of high school math, and sometimes college level math, that sometimes you have to kind of troubleshoot in your brain and you try something and you work through it and it may not be the right option. So I have too many variables, but this is going to be what I'm going to use to replace a variable. I'm going to recognize that y is the square root of x squared plus 4, right? And that's what I'm going to do to replace this y. So I get that time is, I'm going to make this a 1/3, the square root of x squared plus 4. Now you might be saying, Hogan, why didn't you have a plus or minus, right? So I did no plus or minus because the negative is illogical here, right? So the negative wouldn't make sense in the context of this problem because y is a distance and it doesn't make sense to have it be a negative distance, right? Distance isn't negative, it's a scalar, right? And I'm going to go ahead and make this a plus 6/5 minus a 1/5 x. Okay, so that's my time, right? This is the thing I need to maximize, or to minimize rather, right? So to do that, I'm going to differentiate. I'm going to get that t prime of x is going to be, so this is going to drop a 1/2 in front, so it'll be 1/6. This whole thing to the negative 1/2, and again, I would suggest that you get comfortable differentiating square roots, times the derivative of the inside because of the chain rule. The 6/5 differentiates away to 0, and the negative 1/5 x just becomes a negative 1/5. So after all that work, I get that t prime of x is, I'm going to use the 2 to cancel with the 6, so I'm going to get that it's a 1/3. So I'm going to get x over 3 times this square root, right, minus a 1/5. Now, I want to find where this thing has critical points. The easiest way to do that is to get a common denominator. So what we're going to do is go ahead and multiply this thing by 5/5, right? And I'm going to multiply this thing by the 3 times the root over the 3 times the root. This might be a situation where I end up using a calculator. Sometimes, so on the AP, you're actually going to know if you need a calculator to do a problem. Here, we don't always know. So sometimes when you're doing a problem in a textbook, you're not going to necessarily know. So I'm going to get that this is a 15 times this root. Okay, so a couple things to notice, right? So when I look to find my critical numbers, right? When I look to find my critical numbers, t prime equals 0 would mean the top equals 0. Or t prime does not exist. Well, t prime does not exist is not going to happen because a sum of squares is always positive, right? So a sum of squares, right, x squared plus 4, is always positive. So that's not 0, and 15 is a positive number. It's not 0, so that's not an issue. So the only critical number I'm looking to find here is when 5x minus 3 root x squared plus 4 is 0, right? So I'm going to solve for x. Now, the best way to do this is to get everything as far away from the root as I can. So I'm going to make this a 5x equals 3 root x squared plus 4, and then I'm going to square both sides, which I can do because this is all multiplication. So I'm going to get 25x squared equals, when I square the 3, I get a 9. When I square the root, nothing happens, but the root disappears. So I get 25x squared equals 9x squared plus 36. When I subtract the 9x squared over, I get 16x squared equals 36. X squared equals 36 over 16. So x is, now technically it's plus or minus, the square root of 36 over 16, which would be a 9, sorry, not a 9, a 6 over 4, right? Or a 3/2, right? Technically, it's plus or minus, but I'm not going to write the minus because, again, it doesn't make logical sense here. So once I know what x is, right, I now know what x is, I can go back and find y. So we now know that x is 3/2, right? So I'm going to go back up and find y. I know that y is the square root of x squared plus 4, right? So my y is going to, oh, let's double check what I was asked first. How far from the house should the person land the rowboat? Oh, hey, I don't need y. How far from the house? Well, how far from the house is 6 minus x. So I don't need y. So if I go to answer the question, how far from the house? Well, how far from the house is 6 minus x, which is going to be 6 minus 3/2, right? And if you want to make that 6 minus 1.5, it's fine. It would make it a 4.5 easier. So you can either say 4.5 miles, or if you chose to make this a 12/2, you'd get 9/2 miles, and that's fine. So either of those is okay. So again, notice that it took me a little bit to settle on how I wanted to label my variables and what I wanted to do at the beginning, and there's nothing wrong with that. This is a hard problem. There's a reason it's E5. All right, so I want you to try the same one, different concept. Instead of being time, it's now about an oil pipeline. So an offshore well is located in the ocean at point W, which is 6 miles from the closest point, which is point A on the shore. The oil is to be piped to the shore to point B, that is 8 miles from A, by piping that has a straight line underwater and then a line on the shore as well, right? If the cost of laying the pipe is way more expensive underwater, right? So this section is going to be $100,000 per mile, right? And this section, right, is $75,000 per mile. Where should point, so point P is supposed to be right here, right? So how far from point A, meaning from here to here, that's what they want. How far from point A should point P be located to minimize the cost, and what will the cost be? So again, I'm going to label some variables, right? I'm going to go ahead and call this x. I'm going to call this y. We've seen that before. That makes this side 8 minus x, right? So if we want the total cost, right, so the cost of this thing is going to be C equals the 100,000, and I don't really need the units because we're going to 100,000 times y, right, plus the 75,000 times 8 minus x, right? And you can clean that up. So again, I'm going to run into the situation where I'm going to need to use Pythagorean theorem to write y in terms of x, right? So we've seen that before. So y squared equals x squared plus 6 squared. So y is going to be the square root of x squared plus 36, because again, no negative, not because you wouldn't normally write a plus or minus, but because in the context of this problem, it wouldn't make sense for y to be negative. So I'm going to rewrite this so that my cost is 100,000, the square root of x squared plus 36, plus, it's up to you. I think I'm just going to write this as 7,500 or 75,000 times 8, and I'm going to explain why in a second. But the short answer is I couldn't possibly care less right now because I'm about to differentiate, and that whole constant's going to go away. So when I find C prime, right? When I find C prime, I'm going to end up dropping the 1/2 down in front, right? So when I drop a 1/2 down in front, this 100,000 is going to become a 50,000, right? This thing to the negative 1/2 times a 2x, right? Plus this thing differentiates to way to 0, which is why I didn't care, minus a 75,000, right? So I end up getting that C prime is, and I guess I end up with 100,000 again anyway, so 100,000 x over this square root minus a 75,000 over 1, right? So when I get a common denominator, I'd get a common denominator by multiplying by this root over itself, right? And I'm going to end up getting that my C prime is 100,000 x minus 75,000 times this ugly, disgusting thing, right? And I notice that the denominator is a sum of squares, so that's not going to be 0, right? Sums of squares are positive. That's never going to be 0. So my only critical number is going to be when the top is going to be 0, right? So 0 equals 100,000 x minus 75,000 times this ugly root, right? I want to get the root by itself again, so we saw that last time. I'm just going to add that over. You don't have to do this, but I'm advocating that you divide by a lot, like by some big numbers to get rid of a ton of these zeros, right? So I noticed that if I want, I see 1, 2, 3 zeros and 1, 2, 3, 4, 5 zeros, so I can divide and get rid of 3 zeros, and that's going to make your life a lot easier. So I'm going to argue that you probably want to make this 75 times this root equals 100x, and actually you can go a little bit farther. You could divide by 25, right? I could divide these by 25 because that's a multiple they have in common, and I could get 3 root this thing equals 4x, and now your life is a lot easier. So now when I square both sides, I'm going to get 9 times this thing with no more square root, right, equals 16x squared. 9x squared plus 36 times 9, which we'll deal with in a sec, equals 16x squared. So I'm going to get, did I do anything stupid? I didn't, it's fine. Okay, so 36 times 9, again, I'm leaving it as 36 times 9 for right now, equals 7x squared, right? So I'm going to get 36 times 9 all over 7 equals x squared, right? And so then I'm going to get that x is, and I don't need a plus or minus again, so even though technically I'd write a plus or minus, I'm going to go ahead and say no because it doesn't make logical sense here. The square root of 36 times 9 all over 7. The reason I left this as a 36 times 9 is I can make this the square root of 36 times the square root of 9 over the square root of 7. So that ends up just being a 6 times 3. So I end up getting that x is 18 over root 7, right? Which is not the prettiest thing you've ever seen, but it's not the worst thing ever either. So I get this, right? This is my x. And so the question I was asked, if we scroll back up for a sec, and you'd probably make this a decimal because that would make sense here. So where should point B, so how far from A should it be? So the answer was x. So I'm going to go ahead and make this 8, oh, sorry, my bad. Make this an 18 divided by the square root of 7, right? And I'm going to store that as alpha A because I'm probably going to need it again, right? So, so you shouldn't use a rounded answer when calculating other things. So I'm going to go ahead and store that answer and keep it, right? So my first part of my answer, because I was asked 2 questions. First part is P is 6.80, we'll say approximately 6.803 miles. Let's see if it was miles. So miles from point A, right? And then the second piece of information, is what would that cost be? Well, in order to find that cost, I'm going to go ahead and plug into this horrible monstrosity, which is part of the reason that I pulled the calculator out, right? So when I go to plug into that horrible monstrosity, I'm going to go ahead and type into my calculator, right? So I'm going to do 100,000. That's 100,000. And then I'm going to do the square root of, and this is why I saved my A. So A squared plus 36, close that root, right? Plus, and again, no reason not to just call it 75,000 times 8, right? And then minus 75,000x. All right. Oh, sorry, it wasn't x, it was alpha A. My bad. Alpha A. And there we have it. All right. And so again, since I stored it as A, I was able to just type. And this is not a cheap pipeline. I mean, maybe it is. I don't know anything about pipelines. It might be really inexpensive. All right. I guess that they are probably a very expensive thing to make. So, all right. So my answer to the second part is that the cost, right? The cost would be 996,862.6. Now here, I would either say 69 or 70. I normally tell you always go to 3 places, but when you're talking about cost, it doesn't make sense to go to 3 places. If I were doing this on the AP, I would probably write all 3 places, and then I would write that it doesn't make sense to go past 2 places because it's money. So there you have it. That's our rather detailed problem about oil things. All right, that's the end of this section.